Current is the same in all places in a series circuit. Here, current is, let's call it X1. Here it's X1 also. Here too. Here again. But power will vary with a component's ohmic value. Here, the ohmic value is 5 ohms. Power is A. Here it's 10 ohms, power is B. Here it's 15 ohms and power is C. Now if a short occurs, then resistance total is decreased by 5 ohms. A decrease in resistance is an increase in current. And power equals voltage times current, but current just increased. So power 2 then would increase. So a short will necessarily lead to increased power consumption. So, in summary again, resistance goes down, current goes up, power, which equals V times I, and I just went up, so power will go up. And we can see here the old power total gives way to the new power total. Let's have an example. Here's a circuit, 10 volts, with 3 resistors, 5, 10, and 15 ohms. Resistance total is the addition of these, that's 30 ohms. Current total is V over R, and that's 10 volts over 30 ohms. Move that over. 10 over 30 becomes 1/3. V over ohms becomes amps. And power equals voltage times current. Voltage is I times R. Let's substitute that in, and we now have I times I squared times R. That's what power is. So let's substitute. I squared times R becomes 1/3 squared. The current total is 1/3. 1/3 squared amps times 30 ohms. That becomes 1/9 amps, or 1/9 times 30 times amps times ohms. And 1/9 times 30 becomes 30 over 9. Amps times ohms, watts. 30 over 9 becomes 10 over 3, becomes 3 1/3 watts. Let's move this up and put in our values. Power total, 3 1/3 watts. Resistance total, 30 ohms. Current total, 1/3 amps. Now, what about power consumption per component? Now, resistor 1 here is 5 ohms, so PR1 equals I squared times R1. That's I squared is 1/3 squared is 1/9 times the ohmage is 5 ohms, or let's rearrange ohms and amps times ohms. That becomes 5/9 times amps times ohms. Because 5 times 1/9 is 5 over 9. And amps times ohms is watts. So 5 over 9 watts. This guy is 10 ohms. So I squared times R, I squared is 1/9 times 10 ohms times amps times ohms. That's 10 over 9 times watts. Let's put that up there. Next is 15 ohms. PR3, power for resistor 3 is I squared times R3. And that's 1/9 times 15 over 1 times amps times ohms. 15 over 9 times watts gives us 15 over 9 watts. Now, I will not reduce this to 5/3 watts, so you can see more clearly. You can more clearly see what happens to the power consumption per component when there is a short, which is what we're about to have. Oh my goodness, a short just occurred. So, 5 ohms has now been eliminated. Our total has changed. Our total is now 10 ohms and 15 ohms. That's 25 ohms. Let's write that down. The new resistance total is 25 ohms. Resistance just went down. Current total is V over R, or 10 over 25 times volts over ohms. Move that over. 10 over 25, 2 over 5 times volts over ohms, that's amps, 2/5 amps. Write that down. Now, 2/5 amps, 1/3 amps, and not the same. Let's give them a common denominator here. So 1/3 is 5 over 15 amps. 2/5 amps is 6 over 15 amps. 5 into 15, 3. 3 times 2 is 6. 3 into 15 is 5. 5 times 1 is 5. 5/15 and 6/15. And that's what they are, respectively. 5/15, 6/15, the old and the new. Now, PT equals 3 1/3 watts. Let's verify this. Now we're verifying the old stuff. The old values, pre-loss of our resistor. All right, so we've got I squared times R. So 5/15 squared is this number, times resistance, times the resistance total of 30 ohms, gives us 3 1/3 ohms, which is what I have here. So this has been verified. Now let's go to the new stuff, where the current total is 6/15 amps and resistance total is 25 ohms. I squared times R is what power is. So I squared 6/15 squared is 0.16 times 25. That gives me 4 watts. There's my power total. So power has gone up from 3 1/3 watts to 4 watts. So after the short here, power consumption went from 3 1/3 watts to 4 watts. What's the new wattage consumption for each one of these individual components now that the 5 ohm resistor is out of the equation? Well, power consumption for resistor 2, 10 ohms, is I squared times R. I squared, 6/15 squared, times R gives me, times 10 gives me 1.6 watts. Let's put that there. Let's go to the next one. 15 over, this is 15 ohms. What is its power consumption? Power consumption for resistor 3 is I squared times R. 6/15 squared times 15 ohms times amps. And that becomes 2.4 watts. There they are. Let's add them up, and we get 4 watts. Wow. This worked perfectly. Please share and rate this video. This is George Boole, and good luck.